the back side of this, we're looking at number 6, and we're determining the best buy. So the key is you have to find the unit rate, which is the cost per 1 ounce. The first one is cost per 18 ounces. So it's nice to set up a chart. You have $3.96 for 18 ounces. And to do unit rates, this is a good place to use long division practice. You're dividing by 18. Here and here. So since I don't have an edge of my paper, I'm going to just bring in a second sheet so you can see my division. So I'm going to take 18 and divide it into 396. Remember to move your decimal up. And then remember 18 doesn't go into 3, so we put a 0. But 18 plus 18 is 36, so I'm going to put a 2 here and subtract. Does that make sense? So when I subtract, I get a 3, and I bring down the 6. How many times does 18 go into 36? Twice. Good. Twice. Perfect. So 2 times 18 is 36. Yes, John? Shiloh? No remainder. And so that says this one is 22 cents per 1 ounce. So the unit rate for the first one, for the 18-ounce box, is 22 cents per 1 ounce. So we write it like that. Now we have to find the unit rate for the other box. So the other box costs $4.80. How much is in the other box? How many ounces? Over here. How many ounces for the bigger box? How many? 24. 24 ounces for the bigger box. See right here? 24 ounces for $4.80. So we're going to divide by 24 here. So again, this is a good way to think of a long division problem. It's not too hard of one because 24 doesn't go into 4, so we put a 0 here. But how many times does 24 go into 48? 2, right. So you put a 2 there. And then you subtract and you get a 0. Bring down the 0. So 24 doesn't go into 0, so you put a 0. So your unit rate for this one is 20 cents per ounce. So the second unit rate is 20 cents per ounce. So some of you were coming up and I was asking you to write your unit rates. That's what I'm asking you, is to tell me what the unit rates are. So, and then you can circle the better deal. Which one's cheaper per ounce? Yeah, Andy?
It's in a 24-ounce box of cereal.
Right, this is the better deal because it's only how much per ounce, John? 20 cents, right? It's cheaper. Okay? Yeah, we're not gonna have time. I'll have to finish this one after school. So in the beginning of class tomorrow, we'll go over these, but listen up. You can look at the correct answers before you leave real quick on the front side. And, or just real quick if you need to, but I'll also post them tonight. Okay? Okay, so let's start with some basic surface area problems. Not the most basic. I'm going to assume you could do the surface area of a rectangular prism. Yep? Great. True? Yes. So what if we went to do surface area, just kind of, let's do some basic shapes. Pyramids. Make sure you do pyramid. So, again, there's a little bit more difficulty that I would maybe put in here that the book might not. Oh, it's a straight line. And let me show you maybe where that would come in. Just to keep you thinking, about some things that you need. You would need to do surface area. You would need the altitude of a triangle. They'd have to show that at a right angle. And you would need dimensions. So let's say this from here to here is 10. And maybe from here to here is let me just think here. Let me think about some numbers. Hold on a minute. Okay, so I changed that a little bit. If you had a triangular pyramid or a square rectangular pyramid here to do surface area, if you weren't given this eventually, you should be able to figure it out. Anybody tell me why? Yeah, Luke?
Triangle from like the midpoint to the top,
Right.
and then from like half of the distance across the bottom, like rectangle square.
So you would have, if this is truly the height, it would be a right angle and it would form this triangle here. I don't know if I got it connected here. I didn't get it all connected. But you would have a right triangle in there. Sometimes you'll see that missing value in your book. Sometimes you won't. So this is 12, and then since this is 10, this is 5. Can you see that?
Yeah.
Somebody else asked me something.
No, I just didn't see it before.
Okay. So, then you would have to figure this out to be 13 by the Pythagorean theorem. Okay. So you would need this value too here, and this one would not turn out so nice. Can you see that? So this yellow triangle here, you see the yellow triangle is also a right triangle, even though when you pull it out, it doesn't look like one because it's drawn in like, yeah, 3D. So really this would be like this. So if you had this situation, this right here is 4. Can you see that? And then this is 12. But you would have to find this value here, and you'd have to use the Pythagorean theorem. Josh, we'll call it X.
Just because it's triangular prism does not mean that all the triangles are the same, right?
That's right. And technically, I should say this is a right prism. Your book will not do that very often. This is where you could always clarify and say, is this a right prism? But they might say somewhere at the beginning, these are all right prisms. But you have to look at the base. The base here is a 10 by 8, so you don't have all the triangles the same.
So, and the fact that it's a right prism
Means it's standing straight up and down, it's not tipped over. But that means the height is this 12. It goes right to the middle. Does that make sense? So I'm picking a problem that's maybe a little bit harder than what you did 2 years ago, so you can practice some of the skills we've been talking about. So for me to figure out x, I would have to do Pythagorean theorem. And for this one I knew because it's one of those Pythagorean triplets. But here I would have to say x squared is equal to what?
It's 180.
Because you got 16 and 144. Do you see where they got that 4 squared and 12 squared?
Yeah.
So, 170, no?
60.
160. You're right. So x squared is 160. So we have to take the square root of that. Yeah, and here we could practice though, it's 16 times 10, right? And so 16 has a factor pair of 4 times 4. So really this is 4 square roots of 10. Trying to get you guys to practice those skills still.
You don't have to go and do the 2 times 5.
Well, I already know 2 times 5 is not going to pair up.
Well, just like for 180, it's really just if you get 5.
But it's not 180, right?
Oh, yeah.
We can look at that later. Okay, so this should be the goal on a test. A little bit harder than what you might see on the basic pyramid in the book. You might have to look a little bit deeper. I'm not saying on every single problem, but on this test or the next test, Pythagorean theorem is going to keep creeping in. Okay? So surface area now shouldn't be too hard because you have a rectangle, 10 by 8, for the base. And then you have 2 triangles, and the dimensions of those triangles could be a 10 by, what's the height here? 10 by what? So we're looking at this triangle right here, the front face here. So what was this height right here? Question mark. That's not 4 root 10. No. This one. It is this x value right here.
Oh, yeah, it's
4 root 10. Plus 2 more triangles that are 8 by, what's the height of this one? 13. So that would be the hardest about level of the surface area for a pyramid. Does that make sense? And you would just add them up. This is half the base, which is 5 times the height. But there's 2 of them, right? So 80 plus 40 root 10. And this is half the base, but we're doubling, right? So if I did half of the base this way, times the height, because there's 2 triangles, the halves sort of cancel out, don't they? So 8 times 13 is 80 and 24. What's that add up to? 104. So that's 184. If you didn't have a calculator, you would leave your answer like that and just have square units. You guys, put your homework away and do this. This is what I'm asking you to do. If this is harder than your homework, this is what you have to be expected to be tested on. Close them up. If you can't think with your book open, close it up. That's what class time's for, right? You have to push up a little bit. It's supposed to be, remember this book is used for all the levels in the district. So to be the advanced level, it's got to have some push every once in a while. Not always. But this is the kind of expectation that I don't see in your book that I would expect you guys to be able to do. Yes. Cone. We're going to do the cylinder first. Okay. Cylinders should be review. But in case they're not, you know, cylinders basically got a cylinder here. Looks roughly like that with some dotted lines back here. So, surface area of something like this is what it shapes. What do we have? So, a rectangle, right? So you have a rectangle, but it's like the wrapping around a can, right? So it's the same height, but it's going to be wider. And then you're going to have your circles, which there'll be 2 of them. And unless they ask for lateral surface area. What's lateral surface area?
It's just the non-base height.
Right, non-base, doesn't include bases. Okay, so if this was, 20 inches, and this was, what does that look like, about 8 inches, then this is the circumference because it wraps around, right? So it would be 16 times 5. So that's the formula, Robbie, that you might have been talking about?
Yeah.
Because the cylinder that paper has to wrap around the whole cylinder. And so you're going to add the area of that rectangle to the area of these circles. So the radius is 8. So that's 64 pi. There's 2 of those. And then the area of this rectangle is what? It's the lateral surface area. That would be the area of the rectangle. What do you do? 20 times 16, so it's 320 pi. So the total surface area, add those 3. Okay? Does that make sense?
So you have
So 320. Say that again.
you have the curve with pi at the end.
You would have the number with pi at the end. And you would just have inches in this case squared.
Unless it was a calculator.
Unless it was a calculator problem, then you'd hit the pi key and round according to directions.
The pi key after everything.
I would always do it at the end because it's so much quicker to work with pi in the problem. So you guys put your books away. Really? Let's put them away. Turn around. Okay. Pay attention. It's easiest just to do the pi key at the end. Okay. Yeah. If I think I'm going to test you 2 ways. I'm going to give you a calculator half and a non-calculator half. So it depends on the directions. Okay? So what about the cone? So this is a big bonus question. It's hard to think about. But think about a cone for a minute. When you unfold it, here's your cone. It's not a very good cone.
That's beautiful.
It's not a semicircle. It's not.
No, it's like a weird. It's like a weird.
It's actually, it's a sector. It's just a different sector. So here's the question to think about. In your handbook, so when you unfold the cone, you end up getting like a sector. Yikes. So if I took a picture, if I took this and sliced it open, let's say I sliced it open along here, the bottom curve is, how does the bottom curve here relate to this? This is the circumference here, isn't it?
Yeah.
Right? So if you had, say, let me do a better job here. Here, let's make it a little prettier. You have a cone. And you got the height of the cone in there. And your cone basically looks like this, right? And then this would be the height, so they would dot it. Do you know that? You kind of look at it that way. And then this would be sort of a defined view. So a good test question is, if I told you that this was 10, for example, 10 units, and this was 12 units, what would this be first over here? What is this L value, the slant height? What is that? Do you recognize that triangle yet? 13. Just look at that. I use the same one as the last one, 5, 12, 13. So the circumference of the circle, right, this, when you slice this cone open, is right here. Okay? So this is 10 pi. Okay? And the edges are 13. And there's also a circle in here, right? That's the lateral piece. But then there's a circle, the base, right? That's the easy part. So this is, how much is the radius? 5. So this is 25 pi. So here's the challenge for you guys. The area of a cone is this, the surface area. Your challenge is to figure out how to prove that. Not with the little proof in the book where they slice the pieces up and put them together, but how do you actually mathematically prove that? So I'm going to stop at that point because I want you to practice doing surface area before you leave. But tomorrow, this is a great bonus question. I usually put this question on a test every year. Have you derived the formula? So this part's easy, right? So where did this come from? How do you get pi RL out of the 13 and the 10? So I don't want you all to say it out loud. I'm going to stop it. But that's your bigger thing to think about. That's the advanced piece of the cone formula. That make sense? You have to be able to prove it. Everybody should be able to prove it. But the first person that proves it, I'm going to give them 3 test points right off the bat, too. If you can prove it, I'm not saying with pictures, I'm saying with math reasoning. First person to show it clear. Okay? So last part of class is you can try your homework. I'm hoping that those little reviews help you get started on your surface area problems. But this is more of a bonus level. Everybody should be able to do it soon. First one up gets 3 points. Write it down for me and I'll give you points.